In this module, I'm going to be going over equilibrium vapor pressure. Before we can go into equilibrium vapor pressure, I want to talk about two really important topics, evaporation and condensation. We really need to get these two things down and separate them from other terms that are also pretty similar. So if we see this beaker or cup of water, what we will see is a lot of water molecules throughout this container, right? And these water molecules will be held together by hydrogen bonds, intermolecular forces like London dispersion forces, dipole, right? And they'll be in the liquid form. Now, we know from the heating curves module that water will boil and become a gas at 100 degrees Celsius. Now, I'll make another video that goes over the difference between boiling and evaporation. This is a very, very important discrepancy between the two terms, and it's really important that you don't get them confused. Boiling and evaporation are two different things. So if we were to see this cup of water or beaker of water, but instead of being at 100 degrees Celsius, we are simply at room temperature, which is about 25 degrees Celsius. So the water is not boiling. This would be similar to a situation where you put a pot of water on the stove and you haven't even turned on the stove yet. It's just sitting there. It's waiting for you to put rice or pasta or something in there. So the water is just sitting right on the stove and the stove's not on. What is going to happen to this liquid water? Well, every single liquid, before it even gets to its boiling point, will start to evaporate a little bit. So some of these water molecules will escape the liquid and go up into the gas layer above the liquid. So we will see little gas molecules start to form. These are H2O gas molecules will evaporate from the liquid. And again, this happens for every liquid. It's only a little bit. So if you were to leave a cup of water on the table and come back and look at it the next day, you probably wouldn't really notice that any liquid in that container is gone. But for sure, a little bit of liquid evaporated into the gas layer. However, at the same time that gas is starting to form, you will also see some of the gas start to come back down and form the liquid again. So before a liquid, and any liquid, this doesn't have to be just water, and I'll go into a separate video talking about how much gas is going to form with different liquids. But right now, if we're thinking just about water, a little bit of this liquid water will evaporate, not boil, it will evaporate, become a gas, and then at the same time, the gas that's floating above this liquid layer will condensate. So this is condensation. That is a gas going back into the liquid. So there will be this interplay of evaporation and condensation the whole time that this liquid is sitting on the stove without the stove on at 25 degrees Celsius. So that is evaporation and condensation. And one of the most important takeaways to get from this video is that it always happens before you even get to a liquid's boiling point, and that condensation will also be happening. So now that we know these two topics, in the next video, we can discuss what it means to get to equilibrium when we're talking about vapor pressure.